We're now going to start our last session of the Expo's Policy Forum. And this last session is focused on storage, energy storage, EVs, electric vehicles, and grid issues. And one of the things, again, I don't know whether how many of you have been in here for other sessions, but once again, it's really incredible in terms of thinking about how these are all complementary strategies and technologies, and that it's very, very important for us to always think holistically and the vast number of solutions that truly are available as we work towards a clean energy economy in this country. So first up, we're going to hear from Dennis McKinley, who is the Director of North American Wind Power for ABB. Dennis?
Thank you. Sound okay? All right. A couple of points. Got a colleague here that has handouts available if you're interested in them. Just raise your hand somewhere during the session here. She'll get a handout to you. And also we've got a tabletop set out if you want to come out and talk to us a little bit more detail. I guess for starters, thank you for giving us the opportunity to speak with you today. For those of you that aren't familiar with ABB, I'll start off with a little bit of background on the company vision for the United States, and specifically is how it relates to smart grid, renewables, energy efficiency, and our energy future. ABB is a global company with two primary areas of business, power and automation. We employ approximately 140,000 people globally, more than 20,000 here in the United States. ABB and its predecessor firms have collectively supplied roughly 2/3 of the equipment that makes up the high voltage transmission system in the United States. In addition, we are also touted as the largest supplier of electric motors and motor control devices known as drives throughout. In the United States, we've got about 100 locations, 28 different states, major facilities that manufacture products. We also have corporate R&D based in Raleigh, North Carolina. Our corporate headquarters is based in Cary, North Carolina. Obviously, U.S. is the largest market for ABB. From an energy outlook perspective, energy independence requires utilizing all generation sources, plus energy efficiency in transmission, distribution, storage, and end use. Reliable, affordable, sustainable energy is critical to U.S. security and international competitiveness. However, our aging power grid and our long industrial heritage have left us entrenched with some infrastructure that's pretty outdated, pretty archaic. It basically drains energy, resources, and threatens our environment. There are technologies available that we have today that can help make that better. The stress would be we need leaders that can push some of those changes that are required. From a renewable energy standpoint, every hour the Earth absorbs more solar energy than the world's population consumes in a year. And if you find a way to convert that solar energy into electrical energy, carbon dioxide emissions can be reduced. In addition, wind technology is the most mature and most utility scale ready alternative of all the renewable solutions. Though several challenges arise with these alternatives to traditional electricity generation, advanced technologies available today and in the near future will play a major role in more wind and solar energy penetration. These renewable energy sources have assumed key roles in the future of the energy policy. Talking a little bit about smart grid. Smart grid is one of the keys to improving efficiency and ensuring our energy future. Unfortunately, the concept of smart grid is widely misunderstood. Most public and media attention focuses on smart meters, and they do enable things like time of use pricing and give the consumer information needed to make better decisions about how and when they use energy. But that's only part of the story. Other smart grid technologies include wide area monitoring systems that can identify potential problems before they cause blackouts, advanced transformers, power cables, and other so-called primary equipment. The challenge of remote locations of wind farms and transmitting electricity over long distances can be solved using technologies known as high voltage direct current. And we've just recently opened up a manufacturing facility in Huntersville, North Carolina that actually manufactures HVAC and HVDC cables. Approximately $100 million investment in that facility that will be able to help transmit or beef up the infrastructure in the United States. The technologies improve the stability within the grid, and they also provide the ride-through capability during external faults and voltage lags and sags. The other part with the high voltage DC technology is you can connect remote power generation sources like solar and wind power and get them a little bit more efficiently transferred or transmitted out to the load or the demand centers in the United States. Industrial energy and efficiency, which is a big push, tight budgets, environmental considerations, and rising energy demand are all topics when the term energy efficiency is brought up. Approximately 33% of global energy use is attributed to industry. In industry, electricity is largely consumed by large electric motors, which are the workhorses of modern industry. They run machines, fans, pumps, compressors, conveyor belts, and the list goes on. Modern control solutions, automation products, and electrical equipment can run motors and other industrial equipment more productively and efficiently. Energy efficiency makes up energy go further, curbs the emissions, and is a path to meeting sustainability goals without added costs. Saves money through productivity gains and waste reduction, and allows the U.S. to compete globally where utilities and industries are subsidized. Overall, we need to do several things to be ready for the challenges ahead with our power needs. Combination of renewable energy, updated infrastructure that can transmit large quantities of power over greater distances, like ABB's HVDC technology, smart grid implementation that will proactively manage the grid and reduce blackouts and downtime, and a focus on energy efficiency from everything from our homes to our businesses. Given the current trends, power is a critical component to success in the industries we serve, such as electric utilities, oil and gas, mining, life sciences, data centers, etc. Really what we found is the best way to save energy is to be more efficient with how you use it. Thank you.
We'll next hear from Catherine Hamilton, who is the Policy Director for the Electricity Storage Association. And of course, storage is really key to providing much more resilience within the grid and many more options, and can be a real game changer. Catherine?
Thanks. Thank you, and I hope during this speed dating round that you pick energy storage. My name is Catherine Hamilton. I'm with the Electricity Storage Association. We have almost 120 members. These are developers, utilities, suppliers, entrepreneurs. The technologies are represented are batteries of all chemistry types, flywheels, compressed air, pumped hydro, thermal storage like ice and heat storage. So it's a big world out there for energy storage, and I'm going to address 4 questions. One is, what is it? Where can we use it? Who does it help? And how do we get more of it? So the first one, what is it? Right now, our power system is built such that when you generate electricity, you have to use it immediately, or it goes to ground. So how can we capture that rather than just building more power plants to generate more electricity? How can we use better what we already produce? Well, we need warehouses for it, and energy storage provides those warehouses. Essentially, that is what it does. It allows you to store electricity and then use it when you need it and when the price is right and where you want it. So where can we use it then? Energy storage applications are everywhere on the grid. They can be on the transmission side, they can be on community scale, they can be backup for large commercial and industrial facilities, and they can also be in residential applications like with rooftop solar with battery backup. So they operate everywhere on the grid. Who does energy storage help? Everyone. It helps everybody on the grid. It is completely technology neutral. The original plants, and right now they're 98% of what's on the system right now is pumped hydro, and those were originally built to back up nuclear power plants for peaking. But it will take a charge, a battery or a flywheel or any of these technologies will take a charge from anything on the grid, particularly useful for renewables or other dynamic resources on the grid, but also helps natural gas run a lot more efficiently. So it really helps every resource on the grid. It also helps customers because there are no emissions. You can use it when you need it, when the price is better. There's no environmental permitting needed because there are no pipelines. There's no need to site it in a specific area. You can site it in a basement of a building. You can put it anywhere. It allows the grid to become more resilient, more flexible, and allows for more distributed resources. So it is pretty much the Holy Grail. So why don't we have it everywhere? Why isn't it everywhere already on our grid? Now, I don't know how many of you were here when Commissioner Norris was speaking, but he said something totally correct, which is we need to recognize the value of all of these potential opportunities of technology to the grid. And energy storage is one of those where we need to recognize the value so that we can build that into how much does it cost to provide services to the grid. So let's think about all the different policy pieces, because you all hopefully are policy people. And I'm going to give a shameless plug for a bill in just a minute. So first of all, so on the first part of the technology, you need the R&D. So Department of Energy, the stimulus grants, the ARPA-E program, those were really helpful in getting new technologies built, in being able to form partnerships of the entrepreneurs with the utilities, and really starting testing, demonstrating, proving out these technologies. That was terrific. That is one piece of the investment cycle. What else do we need? FERC. So Chairman Norris was here. Chairman Norris described the value that we need. FERC has been enormously helpful in setting the appropriate policies on the energy markets, because if you can reward somebody for what they can do, not reward them for the technology they have, but reward somebody for the service that they provide to the grid, then suddenly the value increases enormously for opportunities like energy storage. State public utility commissions, really key as well. So California PUC just made a ruling in the LA basin not long ago that required 50 megawatts of capacity for storage. Energy storage in the capacity market, why not? This is great, and this is a great way to show that it actually does provide capacity similar to generation. Now, on the direct congressional policy side, there are a couple of bills that we really care about. The most important is an investment tax credit for energy storage, and it's HR 1465 for anybody who's a staffer. Your member should be a co-sponsor of this bill. It is completely bipartisan and bicameral, so we have a Senate version as well, S1030, and it provides an energy storage investment tax credit. So you have to bring private investors to the table first before you can get your tax credit. It is of limited cost, so it has a limit to it, and we feel like this is going to really change the game for energy storage and allow us to scale. Other bills that we care about are the MLP Parity Act. So that one, again, is bicameral and bipartisan, and that allows energy storage companies to be able to organize their corporations as master limited partnerships. That is also important. It's separate from an investment tax credit, which is our #1 priority, but it's also important. And then also provisions to adjust the R&D tax credit so that they allow for pre-revenue companies to succeed and to be able to take advantage of tax credits, because we think that so many of these entrepreneurs and these investors are really at the pre-revenue stage, and yet we want to be able to have them take advantage of R&D credits. So those are sort of our big pushes on the policy side. And we hope that you all will ask us if you have any questions. We have a booth outside, Electricity Storage Association, and I have cards, and you're welcome to call and ask any questions. Thanks.
Great. Thanks, Catherine. Thanks, Catherine. We're now going to look at another important piece of the technology solution. And for that, we're going to hear from Doretta Caparola, who is the marketing manager for Fuji Electric Corporation of America.
Thanks, Carol. Hi, everybody. My name's Doretta Caparola. I'm with Fuji Electric, and for those of you who are not familiar with Fuji Electric, we've been a global manufacturing leader since 1923. Our products range from the smallest IGBT to some of the world's largest power generation systems. With engineering and R&D expertise in power electronics products, it's no wonder that we had already sold over 300 electric vehicle charging stations worldwide when we entered the U.S. market. Since March of 2012, we've obtained UL certification on our 25 kilowatt DC quick charger, and we've begun manufacturing the products right here in the U.S. in Milpitas, California. Manufacturing the products out in California allows us the flexibility we need to respond in shifts in market demand and design requirements here in the U.S. without shipping delays and long development lead times. We're now able to focus on consumer awareness and education, and are focusing our efforts on helping potential station owners understand the business side of installing public charging stations. Typical charging sessions last 20 to 30 minutes, and we're helping them to understand how they can offer charging as a value-added service to their customers, while also creating a recurring revenue stream for their business. Studies have shown that approximately 70% of the oil consumed in the United States is used for transportation. With our corporate headquarters for Fuji Electric located in Edison, New Jersey, those of us on the East Coast were smacked in the face with that reality in November of last year. So some of you might remember that. In the wake of Superstorm Sandy, the East Coast, and New Jersey in particular, was crippled by the storm and the destruction it left behind. Power outages stretched on for weeks in some areas, and gas station lines resembled those from the 1973 oil crisis, just a little bit before some of our times, but it existed. The storm, in addition to showing just how powerful Mother Nature can be, also highlighted our extreme dependence on foreign oil and the need to diversify our fuel sources for transportation. Even as power began to return to towns, gas stations remained out of service as they waited for deliveries that were delayed due to devastation at the ports. This domino effect left a lasting impression and renewed statewide and nationwide discussions on alternative fuel types. In the United States, 94% of cars, trucks, ships, and planes depend on oil. Supporting the electrification of transportation is just one way of reducing this dependence on foreign oil. According to the DOE, there are approximately 12,000 alternative fuel charging stations in the U.S., with roughly half of those stations specific to electric vehicles. As we begin to see an increase in the widespread adoption of EVs, it stands to reason that we'll see an increase in the development of public infrastructure to support this growth. Vehicle owners will continue to rely on residential chargers as their primary source of power, but the development of publicly available stations is critical if we hope to achieve mass adoption. Right now, business owners and city officials can take advantage of federal and state incentives, but what happens when these programs run their course? The EV industry must begin future preparations now to ensure that we can stand on our own when necessary. And in order to achieve sustainability, owners of EV charging stations must be able to tap the potential revenue stream that public charging offers. Although most station owners began offering the charging sessions as a complimentary service, as a value add to their customers, the costs associated with installation and ongoing operation must be offset by adapting a pay-per-use model. In the meantime, it's imperative that the programs offering tax incentives for infrastructure development are extended for a minimum of 5 years. This stabilization of incentives will help in two ways: by offering support during the long sales cycle of EV infrastructure development, and helping businesses justify the installation from a financial perspective. We've seen such incentive programs for the gas industry, and there must be a level playing field with the EV industry in order for it to thrive. EV owners are willing to pay to charge their EVs, so long as the price of their charging session does not exceed that of a trip to the gas station. Paying a few dollars to top off their car? No problem. By educating station owners on the pay-per-use model, we're positioning them and the industry for long-term success and sustainability. Economically, the EV industry can reinvigorate the declining manufacturing sector in the U.S. It's estimated that manufacturing makes up 59% of EV industry jobs. These are high-tech jobs requiring skilled labor, exactly the kind of job growth we want to see brought back to our country. This industry isn't just about getting people to buy EVs, nor is it about getting us to sell more EV charging stations. It's about changing the way our country looks at transportation. Appealing to the business side of the industry will gain the support of key segments such as retail, hospitality, parking lots, municipalities, and more. We need to help them understand how this can be a viable addition to their business. As much as these professionals want to show their corporate social responsibility, they need to justify the cost of adding charging stations. The more they understand about the EV industry, the more they'll be willing to do to support its growth and development. Thank you.
Thank you. And Doretta was telling me earlier that on the West Coast that most people, when they charge, do it for 20 to 30 minutes. It's sort of the same practice that you find with people with gasoline, with IC cars, in terms of wanting to make sure that they're not driving around with fumes, but instead want to make sure that they're, filling up, and that it appears to be sort of the same sort of thing that's happening with regard to EVs, although you fully charge within an hour, right? Which is really, really interesting and good news. We're now going to turn to Dan Arden, who is with Eaton Cooper, and he is going to be speaking on behalf of NEMA, the National Electrical Manufacturers Association.
Good afternoon. I'm Dan Arden. I'm from Eaton Cooper. I'm the product director for distribution automation. Eaton is a member of the National Electrical Manufacturers Association. I'm here representing them. Jim Creevy from NEMA is here, so my thanks to Jim for the opportunity to get to talk to you about volt-var optimization. NEMA and its members have collaborated on an initiative to advertise the benefits of volt-var optimization. We've heard quite a bit about different technologies that can help green the grid. Volt-var optimization is one of those. So what I hope to convey to you is, first of all, what is it? Second of all, I'll talk about the opportunity, and then I'll talk about the regulatory environment and the need that we see to incent utilities to pursue volt-var optimization. So today, electric utilities are required to deliver energy at your house, at businesses, at industrial businesses as well, inside of a specific voltage range. So if you're a geek like me, and you go home and stick a voltmeter inside of the electrical sockets at your house, I don't recommend it. It should be above 114 and below 126. So utilities today have deployed apparatus to make sure that the voltage at your house is inside of that specific range. You think about it, a typical distribution system has around 2,000 customers on a given feeder. A utility with 1 million customers has 500 feeders or so. There are 4 devices that would be mounted on poles or inside of a distribution substation that helps guarantee that that voltage is inside of that range. So it's 2,000 or so devices, a fairly limited number of devices. So what's volt-var optimization? Volt-var optimization is the use of an intelligent control locally at one of those 2,000 pieces of apparatus that leverages a communication network to monitor points in the distribution system and to make sure that the voltage stays inside of that voltage range. I'll come back to that later. Let's shift a little bit over to load. Every appliance load, well, not every, but there's certain types of load that are sensitive to voltage, such that the amount of power that they consume can be linearly or proportional by the square of the voltage. So if we, inside of that voltage range, if the voltage is at the lower end of the range, it would reduce the amount of energy that that particular load consumes. There are other types of loads that are more efficient when they operate like a motor at a nameplate rating. Now, those nameplate ratings are typically closer to the lower end of that voltage range. So if we extrapolate those 2 particular points, if a utility deployed technology that would allow it to manage voltage in its distribution system down closer to the lowered end of ANSI standard range C84-1, that's what they're required to deliver, there's a tremendous opportunity to reduce demand and energy in the distribution system. Let's talk about the opportunity. If we make an assumption that through the reduction in voltage, we can reduce demand by 1%. We could reduce the amount of power that is used across the United States by 7,600 megawatts. The cost savings associated with that deferment in expenses is around $3.8 billion if we price saved capacity cost at around $500 per kilowatt hour. So those are conservative numbers, but there's a real financial opportunity there. If we translate it to energy, the cost savings from energy is around $1.8 billion when you price it at $40 per megawatt hour. Now, the two are not apples to apples. There are certain types of load where if we reduce the voltage, absolutely you get both demand and energy savings. There are other types where what we're doing is shifting the peak. So if you've heard about demand response, we can lower the peak and shift load to the elbows of the load curve, if you will. And that's an important point. While Utilities today operate and plan the electrical grid for peak power. If we can reduce the peak consistently with technology, we can allow them to plan for a targeted investment in technology. Okay. In 2011, the National Association of Regulatory Commissioners, excuse me, it was November of 2012, issued, well, I should first say that NARUC is a body that represents all 50 public utilities commissions, regulatory bodies across the United States and all the states and territories. And they issued a resolution of support suggesting to those bodies to explore mechanisms by which utilities could make a targeted investment in volt-var optimization technology to achieve an operational objective as I described it, reducing demand by reducing voltage. And specifically noted in that suggested that those utilities commissions should incent utilities in deploying that technology by regulatory cost recovery mechanisms in deploying that technology. So if you think about that, the important point of if in deploying that technology, the utility would have to generate less power. They would reduce the amount of pollutants, greenhouse gases that they emit, but they make less money. Revenue decreases. So they need to be incented in some way to make a targeted investment in technology while it reduces a revenue source for them. Okay, let's talk about the regulatory environment. Today there are 20 states across the United States that have specifically drafted energy efficiency regulations. Those regulations are not especially clear, for the most part, about their ability to, or about whether or not volt-var optimization qualifies as an energy efficiency technology. So that's an important thing. Now there are some differences. Ohio and North Carolina in particular, just two examples where the utilities commissions have qualified rate recovery mechanisms for the utilities in those states, and have created a path such that those utilities can invest in deployment of volt-var optimization. Okay, so that's important. So NEMA, one of the things that we want to suggest to you all here as congressional staffers and participants in policy making, we support that NARUC initiative. So there is an appropriate role for federal guidance and support of those regulatory bodies in being clear about the qualification of volt-var optimization for as an energy efficiency technology, being clear about supporting volt-var optimization with revenue recovery cost mechanisms, such that utilities make a targeted investment in software, communications, and discrete controls to reduce demand, per some of those figures that I gave you earlier. I think what Representative Cardenas said around lunchtime was a great point. I mean, the best energy saving strategy is using less energy. That's exactly what volt-var optimization is. Targeted investment where we can reduce the amount of energy that is consumed across the United States. Utilities have been trying the technology. There are case studies that are available. If you wanted to go research volt-var optimization and conservation voltage reduction, you can find material online. The opportunity is real and persistent, and appreciate your support in considering regulation and policy making that can help utilities make an investment in volt-var optimization. So thanks for your time.
Okay, thank you, Dan. And to wrap up our panel discussion is Gary Seifert, who is the Business Development Executive for OSI, and so we look forward to hearing about your technology.
caparolas I saw that were measuring and monitoring the information that comes out of those microgrids. So I've gone from building them to monitoring and controlling them. So all sides of the gamut. So I'm starting with a quick raise of hands. Who's familiar with what a microgrid is? And how many of you are familiar with the fact that a microgrid has to be able to sync in and out of the grid without impact on the system? How many microgrids do we really have in America to do that? Very, very few. We've got tremendous numbers of facilities, of campuses, of hospitals that say, I have a microgrid. But the majority of them do not have the amount of generation they need to do the work, or they don't have the instrumentation to monitor, they can't synchronize, or they can't manage their loads. If you don't know what you have, you really have no ability to go out and do that work. And that's really the message I'm trying to pass on today, is that you don't know what you have. If you're not measuring, how can you manage? And therein lies the title of my presentation, which is the value of data in microgrids. If you don't have the data in front of you, you really can't make good decisions. If you can't make good decisions, then you're not going to probably make your investments in the right places. Now, when you do microgrids, there's some new technology that's been floating around. And the new technology is mainly that of better monitoring equipment. Most of you have heard of WAMs, or Wide Area Monitoring System, which uses PMUs. PMU is a phaser monitoring unit. It uses the GPS satellite to give you a timing signal. And then the PMU is a very accurate volt and frequency meter that tells you what that power system is doing. Now, the nice thing about that is we can actually use that to tell us what the health of the grid is before the lights go out, and help us maybe manage our systems a lot better so that we're better prepared when the system starts to go down. Is that some use? No. We already heard today from the other panels about energy storage. You can use your monitoring system and your control system to determine when you want to use storage versus when you want to use generation. And that's one of the biggest changes we're going to see in the next few years. And if I can make a shameless plug for legislation, that would be to help incentivize these small microgrids, whether it's a facility, a campus, a small municipal utility. How do I access those markets without looking like a utility, without looking like an entity that has all that investment behind it? It's really hard for those people to do that. Another place to look at it is to measure and monitor all your loads. Because what is load management? If I have generation, I can basically take care of my loads, right? But if I have load management, if I discreetly manage my load and monitor my load all the way down, I can treat all of my loads that I'm managing and controlling and monitoring as a generation asset by producing essentially negative load. We don't do a good job of incentivizing people to turn that into very good, high-frequency, high-speed, short-term. And our biggest problem with spinning reserve and grid is not do we have enough generators spinning on the outside, it's how do we manage that first 10, 30, 90, 120 seconds when the grid gets in a lot of trouble because they're very large unit dies and we don't have time to spin them. And first addressed that last year with Order 775. 775 is essentially pay for performance, and it targets that first 1 to 2 minutes. And it allows you to put in very short-term energy investments into your system, which allow you to ride through and give your generators and your governors and your systems time to come up and not go back. So there's a lot of value you can get from those pieces. So when you go out and get your data, don't forget to grab your load, grab your input data, grab your output data, but more importantly, know exactly where you're at in your generation assets. And don't be afraid to take advantage of some of the things that some of the states are doing. We heard it from the electric vehicle charging stations. Within a couple of years, most of those will have to be bidirectional. Why is that? If I have electric vehicles all over the U.S. working, I have literally gigawatts of value I can throw back into the grid for that 1 to 5 minutes. If I can do that and have an awareness of where it is and a knowledge of what the state of charge is, by measuring, then I can manage. So I have a lot of opportunities going forward that we don't have today. But one thing doesn't do everything. All I'm trying to do is basically give you the idea that if you measure and if you manage, then we can all move forward with less and less reserve. Because where's the grid going? We're going to have a higher percentage of renewables. We're going to have a higher percentage of variable loads. We're going to have a lower percentage of very large plants out there because we're shutting down big coal and big nuclear in a lot of places. We're bringing a lot of small generation assets on, and they have completely different time constants. As the future systems come online, people need to be able to know exactly what their performance capabilities are, because those are the ways they can get forward. So storage, better control, knowing exactly what you can give up for just a little tiny bit of time. If you can just turn things back for 10, 15, 30 seconds, that helps a grid recovery. So, can we incentivize it? Can we measure? Can we monitor it? Can we control it better? I think we can. And with that, I'll step down and maybe have some kind of questions.
Thank you. Everything is connected.
Turn the microphone on. You turned it off.
Okay, it's on now. So as I was saying, everything is connected, and our last panel has made that abundantly clear. We do have a little bit of time for any questions or comments. Does anybody want to take advantage of having all these great people here? Surely you're not tired, or go ahead.
Great presentations today. We hear a lot about the technologies and regulations and that sort of thing. Does anybody want to take a shot at speaking to how consumers are benefiting? We talk about grid efficiency, but how are we to make the argument to consumers that technologies that your companies are offering are good for them economically?
Who wants to start?
Start?
Sure, I can start. Specifically, it's pretty easy with VAR optimization. When a appliance runs at its nameplate rating, there are some published studies out there that it will increase the lifespan of the appliance. I've seen one, at least, where utilities said if they manage their voltage at the customer meter closer to 115, which is typically the nameplate rating of a motor, like in a refrigerator in a house, you'll get about a 15% increase in the lifespan of that appliance. So that's one example, Jim, in particular to your question.
So there are a couple different ways. One is, say you have a residential house with solar PV on the roof and you're connected to the grid and you have a power outage. Wow, wouldn't it be great if your solar panels actually could then provide you electricity? But the way it's set up, they usually can't. So having a battery to back up will allow a consumer to understand that if there's an outage, they'll be able to ride out for a little while, or at least keep their refrigerator or other key things running. On the grid side, when you look at, what is a battery on the grid that's providing services to the grid going to do for the consumer? Well, what would it be if we had to get the permitting to build an entirely new power plant? That gets built into the rate base and the consumer's rates go up. So the difference in the cost is significant in doing something that actually allows you to manage your grid better versus having to build a whole new power plant. And that's passed along to the consumer.
I got a real quick response. ABB built and opened up a smart grid center of excellence down at NC State campus, Centennial campus. And basically, it's a great showplace for what a smart grid is or could be. Great consumer interest in that. Basically, you can use software and hardware technologies available today to proactively monitor the grid, what's going on with the grid, look for potential outages coming your way, divert power, things like that, and also get the operational vehicles back out there in the event that you do have a loss and get the power up a little bit more quickly versus people running down with big poles and breakers today. So that's definitely the consumer's best interest to make sure that they've always got power or that they reduce the amount of downtime when they don't have power.
So from an EV infrastructure perspective, it's a pretty direct benefit to the end user and to the consumer. as EV owners, as mass adoption increases for electric vehicles in the United States, we're going to see a greater rise in the need for the infrastructure to support that growth, right? So as people purchase electric vehicles, the first question is, other than in my garage at night, am I going to be able to charge this if I leave the house? Or am I going to have to stay within a 40-mile radius or risk running out on the side of the road? So you really see a direct benefit with the development of publicly available charging stations for the consumer as the EV owner, so that they can, again, drive with confidence and know that regardless of whether they're running errands or taking a trip with their family, there will be charging stations available along the way to support their travels.
Go ahead, Chris.
The most important thing that we see, we provide the historian database that most utilities use, is that as utilities know more and more about their loads, their forecasts, their abilities, they can run lower and lower reserves and still meet their reliability requirements. Anytime you have less reserves online, less spinning reserves, less investment going into future generation, all that reduces the amount of cost that goes into the kilowatt that everybody spends. From a long-term perspective of being in the power industry, what it really does is it slows down the rate increase, because in general, utilities are trying very hard to keep their rates down. They're very conscious of that. And if you can help them reduce investments, to optimize, to run better, to have good historical trends, to have good estimating tools, all those features help those utilities keep their costs down, and if the costs stay down, it's a slower rate increase, and we all love to pay our electric bill higher every year, don't we?
I guess a question that I have is, in terms of thinking about PUCs overall, and obviously there's huge variation among PUCs across the country, just as there is among utilities. And so I was just curious in terms of, as you kind of look at PUCs and you look at utilities, is there overall a really great interest in investing in these kinds of tools, or putting these tools in place, if it also looks like there's going to be a reduction in the sale of kilowatt hours?
Well, from the whole bar perspective, it just depends. It depends upon each particular utilities commission. So Maryland, recently in the last 12 months, I didn't mention when I talked, but they issued an act that said, thou shalt go do volt var optimization. So well, we haven't seen that in other states and other utilities commissions. So it really depends, Carol. I mean, it depends on each body. There are particular areas that may adopt a technology, sooner than others, but there's no logic, I would say, to how that happens.
Which means looking at some of those and using those to then sort of skip ahead to other states or utilities. Okay, any other questions or comments? Sure, over here.
Lobbying against smart meters, and I'd like to, I guess, fortify my opposition to that group, because I don't see that as necessarily being consumer interest, and certainly not the environmental interest. But I'd like to hear some comments from the panel as well on why smart meters are important, and whether or not any kind of threat. I mean, if you agree with that statement.
Who wants to answer? Okay, go ahead, Chris.
Smart meters are the first of many improvements loosely termed in the smart grid arena, right? But what a smart meter essentially does is allow the utility, number one, to read the meter more efficiently at a lower cost, so they have a lower cost of operating, which reduces the cost of power delivered. Second, it allows that utility or that industry that's providing the management of that system a better feel for the actual voltage and the actual performance of their system within their system real time. And if you think of the term of Sandy, we had talked about Sandy earlier, it would have been very nice to have had a robust smart metering system in place, because then the utilities would have known exactly which houses were being impacted exactly which times, which allows them then to do a better job of outage management, outage recovery, outage planning. There's a lot of positives that come from having the smart meters, but is a smart meter a smart grid? And I think sometimes we get confused over smart grid versus smart meters. Smart meters are just a very good tool that does something we've always had. And the information they provide is really the same information that's always been available. It's just at a higher resolution. And why is that important? If I'm a utility or I'm a power plant producer giving power to the system, I need to know when that power is coming. And if I can use smart meters to fine-tune how that power is being used regionally, I can pick my assets better, I can pick my generation better, I can use the right generation at the right time without spending a lot of extra money a long ways away and bringing it in over the power lines. I can also balance that against some local storage. And again, that goes back to the EV world. It'll be a short time period before we're using EV batteries and other localized storage to really help, and the smart meters provide the information to the planning people so that they can properly locate those assets for the next phase of the smart grid.
I would just echo what Gary said. Simple use case. How many people, when their power goes out, immediately calls the utility? Okay, if you don't have a smart meter, the utility has no idea that your power is out for the bulk of the number of outages, because they're usually on a small scale. Tree falls down and takes out the particular phase that your house is being powered for. So the first thing is, anytime your power goes out, call the utility, because they need to know, unless you're served by Pepco, who has a deployment of smart meters. With smart meters, they get a last gasp notification indicating that the power is out. So there's, for the bulk of the outages that occur, not Sandy-like, trees falling down, it's a benefit for you directly, because the utility knows that your power is out and they can automatically route a crew to drive to what is the likely location of the outage.
I guess that will be the last word. I want to thank you all for being here, and thank you to our panel. Lots of information. Please feel free to follow up with everybody, and thank you for being a part of this whole forum and expo. Thanks.